And actually, time-varying characteristic of distributed networks makes the measurement data of intelligent instrument in the same state not enough, which cannot satisfy the required amount of data in existing topology topology identification. So that means actually we have the uh, so actually the key problem is that actually it is the multi-collinearity bring challenges to topology identification. That means we unable to identify loop networks and the measurement data in the same state is limited. That means we only got the small data size. And here's a review about the current research status and problems. And so we do the work based on the partial correlation analysis. Actually, and we can see the left picture where the color in the square represents the correlation coefficient among nodes. And that means the closer the color is to yellow, the higher the correlation between the two nodes, as well as higher likelihood that the nodes are connected. So the PCA efficiently remove the effect of the collinearity and reveal the connection between two considered nodes. The partial correlation coefficient between neighboring nodes is close to 1, and between non-neighboring nodes is close to 0. So considering the PCA can reveal the intrinsic correlation of two variables by eliminating of the influence of the other variables, we propose the PCA-based topology identification method. Here's a basic framework. Actually, we division the big problem into 3 steps problems. And firstly, the maximum spanning tree of network is generated through the priming prima method. Then the loop of the network are identified by taking tree neighbors as controlling variables in PCA. And finally, a new topology verification based on PCA is developed to correct the wrong connection caused by the multicollinearity. And we do the case study on the IEEE 33 node system and IEEE 123 node system, and also the real 49 node distribution network in China. And here are the results of the topology generation process and calculation results of the different example systems. So we can clearly see that the identification of the loop network is realized and the application scope of the existing method is enhanced, and the error caused by the collinearity is corrected, and the accuracy of the topology recognition is improved. And meanwhile, we do the test in the system, including the distribution energy resources, and we can also find that the method is suitable for the ratio Marshall or even the distribution networks, including the distribution energy resources of different scales, and has strong robotics. And actually, we have the vivid map and can help us to show the status of the line. It has a really huge application scope. And based on this work, actually, as I introduced just now, actually we do not have the enough data size to do the joint estimation about the topology and the line parameter. So the key idea is that actually we have the really enough physical knowledge about the pop system. So if we take use of the good physical knowledge, it can help us reduce the measurement data required for the data-driven methods. So we propose this method. So this is the basic framework of the proposed method. So based on the spatial characteristic of the distribution network and partial correlation analysis based on neighbor node selecting method is designed, and the initial topology and the small data size was robustly identified with all criteria and combined with the linear power flow equation, the initial value of the line parameters and the phase angle are estimated based on the linear regression. And furthermore, the initial topology line parameters and the initial phase angle are optimized based on the Newton method with the decoupled line power flow model. So details can be found in the paper. And we also do the same test case studies, and the results show that the proposed method can accurately estimate the topology and line parameters of the distribution network with different size and types using only dozens of measurement data. And compared with the listing method, the proposed method only needs small data size and has faster calculation speed with the same estimation accuracy. And we also do the sensitive test results show that the proposed method is robust to noise and sampling resolution.